Well, thank you all for coming to my talk today. I appreciate that. I want to be respectful of your time and start on time. The title of my talk is Type Providers Making Data First Class. So I want to start with a definition of what a type provider is. Basically, a type provider is going to, here's what happens. You will give it a live connection to a data source, whether it's a CSV file, XML, SQL, whatever, and it will run out at IDE time, examine that source, and create a schema for it, and it will create erasive types for that schema, and it will enforce those in the IDE at IDE time, and the compiler also has access to those. So I want to go down a walk on memory lane for just a moment to set kind of the stage so you can kind of get an idea where type providers fit in. A long time ago we had untyped lambda calculus, and that seemed like this was the answer we were looking for. Everybody could go home, problem solved. And it does solve a lot of problems by just avoiding mutation, but then types came along, and I'm an old timer, so I lived through a lot of this and actually witnessed it happening. And I remember at the time it happened, there was a lot of discussion about this, because when you have typing, as you see from my Venn diagram, you restrict the code that is possible to express. You're narrowing the set of code that you can express, because the type system will reject some programs that are absolutely correct, but it can't prove that they're correct, so it has to reject them. And so this was kind of a demarcation boundary for some people decided, don't bother me with this type system stuff. I know what I'm doing, and I'll get to that a little later. But anyway, the type system adds a lot. Untyped lambda calculus and mutation-free is not sufficient. We need types. They add a whole lot to the overall picture. So back in those days, I remember the debates that went on. Dynamic people used to say things like strong typing is for weak minds, because remember around this time in the early 80s when Lisp machines were in vogue, they actually had a tagged architecture, and they would recover type information at runtime using the extra tags on the registers. And you could pass anything to anything, and as long as the typing was okay, right at the last possible moment, it would say okay. And at that same time, we had things like Pascal, and we were starting to get a notion of type safety, but we had monomorphic typing, and the type safety in Pascal, to a lot of dynamic people, they just felt, this is nuts, I don't want to be bothered with this. And they kind of felt like, I know what I'm doing, leave me alone. They felt like the type system was kind of like a bitchy mother that was telling them to clean their room up, and they said, don't bother me. And the static people were saying, no, you don't know what you're doing. Your code makes paying stakeholders lose sometimes. And the debate kept going back and forth. The dynamic people would say, well, we have the ultimate expressive power, and we can even do Y combinators, whereas you static people, the type system won't let you do that without cheating. And the static people say, well, I can live a useful life without the Y combinator. And the dynamic people actually at this juncture had a very good point. They said, the type systems are way too complicated. I have to have a PhD. I spend more time messing around with the type system than I do doing actual programming. And there was a lot of truth to that in the early days, but it's getting better. But ultimately, I think the static people won this argument because they basically say, we don't like surprises at runtime. And I think that's what wins the day. But if you're still in the dynamic camp, like the dynamic scripting type languages, type providers might not be for you. Okay, so just for a moment, I want to kind of think about having two knobs, one being static and dynamic. And by dynamic, I mean something is so dynamic the compiler doesn't know enough about what's going on at compile time, and so it says, you know, I'm just going to have to stick stuff in your code to do runtime type discovery and hope everything works out. I hope you know what you're doing, and I'll try and help you as much as I can, but I can't help you very much because I just don't have enough information. By static, I mean the compiler knows a lot about what's going on at compile time and can do a lot of analysis and make a lot of interesting decisions. So type providers are a thing of F#, and F# prefers static typing over dynamic. If you want to get just kind of a bird's level view of F#, imagine taking that static knob and cranking it as far as you can go up the static way, and then the dynamic knob and turning that down as much as you possibly can. F# is strict by default. Interesting thing about this, the downcast operator, upcast operator, I really like the way they represent that F#. Notice the question mark in the downcast operator? That's kind of a little clue to you that, hey, I'm going to inject code to try to do this cast at runtime, but it might fail. I can't guarantee it's going to succeed. I hope you know what you're doing. Whereas the upcast operator, the compiler can assure that it's going to work at compile time. Okay, so, I'm going to skip this other thing here. Okay, so if you're on board with me about type safety is important, now we have a big question about when do you want your type safety? And us F# people, we want it as early in the game as possible. I mentioned before that in list system, you could pass anything to anything as long as everything looked okay at the last possible moment that you could get away with it. The downfall of the Lisp tagged architecture, I think, in a lot of ways, was the Haskell people were starting to come on the scene with type inference. It was really starting to work nicely, and they could do it on stock hardware. It's hard to compete with free or cheap. Okay, so if we can have type safety at the IDE time, basically, you're looking at the IDE, and if there's no squiggles, you know it's going to compile. You don't even need to call the compiler to find out. If there's no squiggles, you know it's going to compile, and if it compiles, it's probably going to run as well. Okay, so to pull this off, type providers have to be very fast. They can't make the UI unresponsive. That means they have to be capable of very sophisticated analysis, because they have to provide a lot of information to the IDE and the compiler. And FP is functional programming is ideally suited to this. It's almost like we're moving toward artificially intelligent compilers, and type inference is a huge step in that direction. Essentially, it's like having a Prolog engine running all the time while you're in the IDE to work out your types for you. That's pretty cool. Okay, so F# was the first language to come out with type providers. Idris has them. That's Haskell with dependent types. And I'm way outside of my area of expertise here. So I'll just kind of defer here and say that from what I've heard from Idris people that have tried this, that this type provider implementation in Idris is a bit different than in F#. And that's all I can say about that, because I just don't know enough firsthand. And Haskell's trying to, Haskell has a movement right now to try to come up with type providers, but when I looked at their website, it seemed like it was more wish list items than actual testable code. Okay, so once upon a time, in the old days, we just had to worry about compile time and runtime. And then there was compile time, link time, and runtime. Now it's really gotten more complicated. We have the IDE, and we have very rich IDEs, and then we have the compile time, and then the idea of building and whatever happens at that time, linking and so forth. And then we have the test phase, and then we have the packaging phase and deployment time, and then finally we get to runtime. So now we have all these extra different hurdles to jump through in the development cycle. And the IDE is kind of pushing the envelopes of compilers as we used to know them, because now they're having to be more like a service that has to provide services to all these different phases of the cycle. So the idea behind type providers is we want to find out about failures as early as possible. Instead of at compile time, that's too late. We want to push it into the IDE and find out everything that's going to go wrong in the IDE. Another aspect of type providers besides just this is they're wonderful to just give you a tool for exploring data sources, because when you connect to your data source and have Intellisense and can walk through your data source with Intellisense, it's a great way of exploring it. It adds something kind of like entity relationship diagrams adds a lot, but these add even more because you have the type safety and so forth. So between this and ERDs, you have more tools to help you understand how the data is laid out, how it relates to each other, and things of that sort. So it's wonderful for trying to explore a data source and learn what it's like and the domain aspects of it. So the functional programming community has a wry sense of humor, and they like to talk about TDD. Normally, TDD stands for test-driven development, but some people have absconded with that and say it really means type-driven development. And they point out if you're relying on your test suite, you're too late in the game. Test suites are too slow, they're too late, they're too incomplete. If you can design your code in the first place using a very sophisticated type system to make it impossible to define illegal states in the first place, and then you don't have to test for them. And so type providers are really going to try to push the envelope to help that become a reality. So you've all seen what Intellisense looks like. You know, it looks like this. You start dotting in and you're seeing all this stuff like this. So you're getting all this feedback, and you're able to dot through your data source and get little hovers to tell you what the types are. This is really nice. If there's something wrong, you get a squiggle. This is interesting. Sometimes I've been using a type provider and the database goes down. Well, I'm the first one in the shop to know that the database went down because I get squiggles all of a sudden in my IDE. And I say, oh, the database must be down because all my code is marked up with squiggles when it tries to access the data. So it's really instant feedback. And when something's wrong, it tells you what you need to do to correct it. That's also nice. Some people don't like the idea that you have to have a direct connection to the database because their build process, or for security reasons or other reasons, they say that that's a challenge for them. But if that's an issue for your shop, Google, there's lots of antidotes to that, and I'm not going to go into that any further. And here's a cool thing. If you go and change your data source, all you have to do is rebuild, and then the schema gets instantly remade just by rebuilding your code. And then it adjusts accordingly. Things that used to be errors are now fixed, or vice versa, depending on whether the changes broke your code or not. Well, this is a great way to find out about it. So I want to tell you what type providers mean to me as an old-timer, having been through the scheme days. And one thing about the scheme days that I hope has not been forgotten is this idea of first-class citizenship. The scheme people were really keen on driving this home to people. They had this idea of, okay, if you can put ints into an array, you should also be able to put function definitions into an array. Otherwise, functions are not first class. And they took this to extremes. And it was really a good eye-opening experience to point out how many things that we have in our conventional languages that are not first class. For example, if tests. Why do we have an if command and an if function? We have these discrepancies and gotchas because we weren't thinking in terms of making things as uniform as possible. When things are as uniform as possible, life becomes a lot simpler and easier for both the language designers and the language users. Another thing that we get with type providers, we're not only connecting to the data source, we're lifting the data to a higher level of type safety. CSV is the lowest type safety. it's easy to forget a column, and then you don't have the same number of columns on one row as the other, and mistakes like that. Type providers can catch that for you right away. XML is a little better off in terms of type safety, but you're still doing a lot of conversions of strings to data types at compile time and runtime, so that's not quite as nice as other data sources. The database maybe is a little better, and of course in-memory data is the very best. So imagine making everything first class. So regardless where the data comes from, it's a first class citizen with F# type safety, and you can mix your queries and get some parts of your query from a CSV file and some from a database. This is useful if you're going to sanity check a CSV file before you actually do insertions into a database. Make sure the data is consistent and so forth. All right, so I want to say a few things about type incoherence in SQL. They did get some things right. For example, how many people are aware that nulls are incomparable in SQL? There, you know, yeah, see? To SQL's point of view, a null indicates an absence. And from the SQL point of view, an absence of bananas is not the same as an absence of strawberries, for example. And so they're inherently incomparable. But C# and other languages take a different view. They just think of null as being an absence. We don't care what it's an absence of. And this causes some people get tripped up because your queries don't return what you think, because you're saying if something equals null instead of if something is null, and you get completely different results as a result of that. Joins are a great case in question because I'm looking at a result set that came from a join, a left join. A left join means if there is something in the right table that is a counterpart to the thing on the left table, we'll put it in. If there is no counterpart, we'll put nulls in for the right-hand side. And then I'm looking at this result set and I say, why is this column null? And I look in the schema and it says, no, this column is not nullable. Why is it null? And then I realize, oh yeah, that's right, it came from a join. So this is what I call a type pun. Null in that case can just mean there wasn't anything on the right-hand table. So now we have these nulls meaning different things. The type providers try to clean up as much of this stuff as possible. Another thing, notice this example here where you see it says people by person ID and state provinces by state province ID. In SQL, they only care about the type safety of your IDs are normally ints. So as long as you have an int on the left-hand side, int on the right-hand side, you're good. But the problem is that you might be using the wrong foreign key to go to a different table, and this guarantees that you're going to the table through the right foreign key. It guarantees that at IDE time. That's really cool. Let's see, how am I doing on time?
Almost a whole half hour.
Oh, I do. That's good. Cool. So I want to talk a little bit about erasive versus generative. Most type providers are erasive, and there's a very good reason for that. But first I want to explain a little about erasive versus generative. How many people know what erasive types are, just out of curiosity? Okay. So erasive types are a fiction of compile time. They don't exist at runtime. There's an upside to that, and there's also a downside to that. The upside is there's no performance penalty. You can have very, very sophisticated types, and if it's an erasive type, it's going to get emitted as a raw native type. So there's no performance penalty if you're doing a tight loop in like assembly language. Imagine that's a big deal, right? You could lose a lot of time if you have a lot of overhead for a sophisticated type. So basically what the compiler is doing is it's saying, I have this little crib sheet here and I'm keeping track of things, and I'm creating these types just for my analysis purposes, just to make sure your code makes sense. And then once I figure out what kind of binary I'm going to emit, I just erase all that stuff. That was just for analysis. Those are my crib notes. Now, there's a good example of, to kind of get an idea of what erasive types are. The old C arrays, remember those? You have to pass the, one caller has to pass to the callee what the bounds of the array are. And so now the onus is on you to make sure you get that right. And if you get it wrong, then you can reference past an array. And that is terrible. The compiler should take care of that for you. This is a great example of a type that was done as an erasive type that should have been done as a more dynamic or generative type. You want some sort of runtime around, or some sort of code around that can do runtime type discovery and find out what the upper bound of that array is at runtime, or even at compile time, so that you don't have buffer overflows. One of the downsides to erasive types is if you're in the debugger and you're looking at this, there's no way to reflect on these things at runtime. There's no runtime around to help you make sense out of these types. So the generative ones usually are based on some sort of runtime that have some sort of library that know how to provide methods like length and so forth that you can call. And it requires some additional code. If there's no runtime support for a type, you can still have the compiler emit some extra code to do some runtime type discovery. All right. So the only thing I want to point out here is, I was just thinking a while back, how come we haven't seen erasive types before, or type providers before? And I think a big part of the reason why we haven't seen type providers before is it took the power of functional programming to bring this to us, because it's really hard to write really complicated, sophisticated analysis code using mutation. It's hard to guarantee it's right and hard to reason about how to do this. And so FP is just the right thing to bring this to us. Type inference also helps a lot. When the type provider goes out and looks at your data source, it's doing type inference based on the examples you provide, and it can infer what the types have to be based on how they're used in that example that you give it. There is in F# this thing called units of measure, and I think F# invented it. Am I right on that? F# is the first one to come up with units of measure and type providers. Units of measure, as you see here, these are very sophisticated types, but they're erasive. They are a fiction of compile time. And for example, you have the units like pounds per square foot and so forth. And when you do math with these, it cancels out the numerator and denominator appropriately for you and works all this stuff out for you. But then when the compiler's done and emits your code, it knows that that thing that was pounds per square foot is really a float, and it emits the raw type, and that's when you get the speed advantage of a native type, but you get the type safety as if it was a really sophisticated type. That's pretty cool.
Those other Meulebrouck trees that I could be wrong, but I don't know.
Right. And you can define your own units of measure. This was kind of a way to solve the Mars rover very expensive mistake. You remember what happened? One team was using imperial and the other was using metric. Boy, I would not want to be the one to have to explain that to paying stakeholders. So the interesting thing about this units of measure, I think it was only a matter of time before they realized, hey, all we have to do is add a few steroids to these unit of measure things, and we can, do really crazy stuff like have type-safe data sources. And so basically, if you want to think of type providers in a tongue-in-cheek kind of way, they're kind of like units of measure on steroids. All right, so we're going to get IDE type support. And part of the reason why we want this type support is this is interesting. It's hard to create a compiler that can spot logic errors. That's a long way off, if ever. But here's that interesting thing about a logic error. oftentimes when you make a logic error, you also step on the type system. The compiler can't tell you the error in your logic, but it can definitely tell you when you step on the type system. And often when you're looking at why did I get squiggles on this thing? What's the problem here? And it tells you what the type error is, and you realize, oh, my logic was wrong too, and you fix both of those things at the same time. Okay, and I'll mention that I like the fact that if you change your data source, you just rebuild and it remakes the schema. One thing I hate about ORMs is you're always wondering about drift. Have I drifted? Has my data source changed? Do I need to do a migration? Can I rely on the migrations, or are they buggy and are they screw my database up? So to have all of that out of the picture is nice. A lot of times when I work with ORMs at work, because I have to because they're part of legacy systems, all kinds of things happen at runtime, and I thought, why couldn't the compiler tell us about this? And this is why I like type providers, because they're much better about spotting things early in the game. So a lot of people hearing about type providers from other languages have asked questions about, can you kind of explain what a type provider is to Haskell people and other people? And I'm kind of out of my area of expertise here, but some of the things that people are saying is that Haskell templates that are kind of like type-safe macros, that's a step towards these type providers, but it's not quite the same thing. The real key takeaway of a type provider in F# is the tightness of the integration with the IDE. And I want to call your attention to something. I didn't make a slide for it, but I'm going to point it out now. How many people know what B4? Hopefully you've never heard this before. I think I just made it up. But build it in from the onset, right? If you're buying a car and money's no object and you really want to go first class, put the navigation system and all the goodies in as built-ins from the onset rather than aftermarket add-ons, because aftermarket add-ons are never the same, don't give you the tight integration of a built-in system. So the idea of a type provider is we're going to make the compiler so it knows about these from the onset instead of tacking these on as an afterthought.
Question. So by IDE by IDE time, you mean that this thing will actually compile, even though the IDE shows through.
No,
right? Or it's also not going to compile.
Right, exactly.
Okay, so IDE gives you early warning.
Yep,
But it's not like a warning, it's sort of like an error.
Right, it's an error.
It's going to front. So.
Total error, and that's why I said
Okay.
the whole idea of development now is a game of, do I have squiggles in my IDE? If I don't have any squiggles in my IDE, I don't need to call the compiler to see if it's going to compile. I know it's going to compile.
Do you have an option to make it into a warning as opposed to an error?
Well, no, because
So the scenario will be this. I'm writing a migration script from old schema to the new schema. Right? So my code base needs to be aware of both the old and the new schema in the database. Now, one of them is not going to compile.
oh, okay, so let me stop you there. So the way I would do that is to, hopefully you have the
Two databases.
two databases, great.
Okay, I understand. Okay.
So now
Let's plug into different.
you're going to have a type provider for the one and one for the other, and you can do joins.
Okay.
This is the cool thing about type providers. Remember how hard it is to do SQL joins between one database and another. That's hard to do. There's ways to do it, but it's really difficult. The type provider is just, I can do joins with the old schema and the new schema, a CSV file, and all these things, and mix them all up in any way I want. It's really, really nice. Of course, and I don't want to oversell this. I mean, there's always caveats. Pick your poison. There's no nirvana. There may be little things here and there where there's some abstraction leakage, which I'm going to talk about next. But basically, this is a pretty mature, very mature and solid technology. I feel much more confident at work if my code has a type provider than if it has an ORM. Speaking of abstraction leakage, here's the way it works. you give you give a connection string to some data source, and you're telling the type provider, this is my sample. And so it goes in there and does type inference on that, and it works out the types based on that. But here's an obvious problem. What happens at production time when you're not looking at your dev database, you're looking at the test database? What if there's some drift between those? That could break things. And there's just no way around that. That sounds really dicey, right? That might scare you off and think, oh no, but it's not insurmountable at all. Really, in reality, I've only really been bitten by this once, and that was with an XML type provider. The XML type provider lets you specify multiple samples. You don't have to just come up with one sample. You can specify as many samples as you want. Of course, the more you specify, the more it takes to do the type inference. What I did was I thought a certain node would have 2 elements in it, and some data out in the wild surprised me and had 3 elements, and the type provider threw an error at runtime. And because it's doing some sanity checks at runtime, it said, hey, you told me this thing was only going to have 2 elements, and here you provided 3 elements. And I just thought, oh, okay, I'm glad to know that. And I added another sample into my sample to take care of that. And I had a better understanding of the domain about what the shape of these things looks like in the real world, and I just moved on. And so it helped me spot that. Another problem that can happen with these, let's say your database is on the moon and there's some latency going back and forth between the moon. That can slow Intellisense, but even that's not insurmountable. There's ways around that by doing caching and asynchronous processing to ameliorate that. Okay, here's another problem. Let's say my type provider's in F#. I did my backend in F#, and my caller is a C# caller that doesn't know about the richness of the F# world. And I'm gonna hopefully, how am I doing on time right now? Oh, good. Generally, when you want to package things up, you want to only return just what you need. Don't return anything more than what you need. And generally what you do is you package it up as an F# data type that will translate nicely to C#. Anonymous records is a great way to do it now. And the interesting thing is we have some type inference in C#, nothing to rival F#, but it can still do it. So I'll try and show, if I have time, an actual, what it looks like from the catcher's point of view and what it looks like from the F# point of view. Interestingly enough, the anonymous records look like POCOs, and the records in F# look like POCOs in C#, and it's really cool. I didn't have to make a POCO on the C# side to be able to catch one of these. There's type providers for just about everything, CSV, JSON. They're not Microsoft-centric. F# is not Microsoft-centric. It tries to be as ecumenical as possible. What the caveats are depend on the type provider. And there's lots of choices. You might have like 3 different choices for a certain type provider, and you can look at the different ones and see which one suits your purposes the best and read what the caveats are, whether it works for Postgres or whatever database you're working with. Here's an actual piece of code. I want to point out, notice where it says literal. Now here's where we're kind of pushing the envelope of compilers in the old days versus the new days. That literal there means I want this thing to be a constant at IDE time. If the compiler made it into a constant at compile time, it's too late. I need to be able to see this as a constant at IDE time. And so I put that decorator on there. There is only a certain amount of evaluation that can take place at IDE time. If you were to put in here, try to access the connection string from a config file, that won't work because that's too much evaluation at IDE time. Maybe in the future they'll change that, I don't know. Okay, so I give it my local dev copy of the database, and then I've got a connection to that. Basically, that one line of code where it says type SQL equals SQL provider, basically that's all I need to do to get my type provider connected to the data source and have it do all its magic for me. The other thing I want to call out here is see where it says use option types true. You can turn this false. What this is we're not just trying to access the data and provide it at IDE time with Intellisense. We're actually trying to clean the data up and lift the data. And this is one way that you can lift it. Anytime there's a null in SQL, I want it to be converted to an option type, which is a maybe type in Haskell. And by doing this, I've caught all kinds of slippery null problems that I otherwise probably wouldn't have been able to catch. And then I do the let ctx equals get data context. Now, notice how I can pass it the connection string there. If I gave it a unit there, that means I'm just using my local database, and that's not going to work when I move it to production. I need to call it with a connection string so I can change that out at when I deploy time so that it can see the production database. And that's where he had the possibility that my samples might not match the actual. But this is how you do the swap out. And here I'm using my favorite type provider, which is more link-based. Everybody know what link is? Language integrated query. C# has it, but F# has it in spades and steroids. And I just kind of like working with this type of type provider rather than SQL because it's much more sophisticated. It's the way SQL should have been. So in this case, I'm just returning just an array of these different keywords, but this is kind of naive code. I'll try and show an actual example that's a little better than this in an actual IDE. So how am I doing on time?
Like 12 minutes.
12 minutes? Okay, so type providers can take the act as replacements for ORMs entirely. They're less opinionated, they're lighter weight, they're kind of like micro ORMs in some ways. They have a lot of same functionality as micro ORMs. And we hear a lot of code first and so forth. Well, the tongue-in-cheek referral of these is this is code last. This isn't just database first, it's code dead last. And this works fine with normalized databases. A lot of times ORMs want databases to be denormalized in strange ways that are conducive to the way the ORM thinks about things. But if you want your database totally Boyce Codd normalized, no problem for. In fact, however you want to normalize or denormalize your database, the type provider will still work just fine with it. If you want to see the SQL that gets generated, for being a Microsoft guy, I use SQL Profiler, but whatever your profiling tools are, you'll be able to see the traffic from it and see what the resulting SQL looks like. These are extensible. You can create type providers for anything you want, but they're not for the faint of heart because they're difficult to create and debug. Okay, so quick recap, and then I want to show some a very small little actual code example. So we saw 4 tricks here. We're using functional programming. We're using types. We turned up the static knob and turned down the dynamic knob, and we have first-class citizenship. These are the bag of tricks that comprise type providers. This is a way of making data it's a way of making data first class and providing everything at IDE. And the compiler enforces these, and we can mix disparate data sources. So this is all the stuff we went over. Here's a challenge for you. Try implementing these in other languages. I'd love to see what they will look like in Rust and Haskell, so forth, and see if you can push the envelope beyond what F# did with them. So, okay, so a quick concluding remark in the way of a polemic. As I see it, you've got 2 choices. You can either have a dynamic type system where things go wrong and you grovel in the debugger after things go wrong and the stakeholders lose. Or you can play a game of chess with an artificially intelligent type inference engine at IDE time and work out your problems then. Given those two choices, I'll definitely want to play the game of chess with the artificial intelligent type inference engine at IDE time, because I just don't like having to answer to stakeholders when things break, and it was stuff that could have been caught at compile time. So that's my take on it. I'm going to skip this, and I want to show some actual code here, even though showing actual code is dangerous. Okay, so here's just a very simple case where I'm going to type on this, hover this, and notice here it says it's a cities entity. The type provider created that for me. Now, I would never do this in practice, but now let's see what it looks like from the C# side. C# side uses type inference by var, and let's see what the type is. Oh, look, it's SQL entity. Let me do that again. Just notice what that was. Cities entity, and now it's SQL entity. We lost some information. Here's what an erasive type is. The .NET runtime doesn't have enough richness to express F# types, so they are a fiction of compile time and IDE. And you can see the actual data structures. If I were to look in the debugger, I'd see all the stuff there, but I wouldn't know how to interpret it and comprehend it, because that knowledge of how it's laid out is gone. And I could figure it out, but I would not advise you to do that. There's a lot of meta information there. It's more than you need. You might think you understand how the metadata is used, and you might be wrong. And even if you do figure out correctly, they're free to change it if they want. So you're depending on undocumented stuff. So don't ever do that. What you would do instead is you would just return the things that you need in some sort of F# record or tuple or something like that. Another thing I wanted to point out here is this, what I call join safety. So here I have a query. It knows about the countries. And then and I'm going to get rid of this just so you can see what the Intellisense experience is like. I do a dot, make a liar out of me.
I think it's unique, so it doesn't have the collection string.
Oh, no.
Yeah.
I didn't fully erase it. That's the problem. Oh. It's the common sense stuff that will get you every time. There it is.
Okay.
Now, see here where it says people by person ID. That means if you want to go to the people table, I'll take you there through the foreign key. It knows what the foreign key is. And this way, I don't have to specify, because a lot of times I get mixed up and I use the wrong foreign key. And since they're in, SQL would say, hey, that's OK with SQL, but that's not join safety. That's raw data safety. So that's a very nice thing. Now, I want to show on here. See, these are I'm actually walking through all the columns that I can possibly pick. Or maybe I'll pick country type. And I'll actually show you what it's like to actually walk through the entire database. Application, this is kind of like DBO, and then I'll say, oh, I want that one. Here's every single table in that application, which might be DBO or some other thing. And then I pick, I think I'll take cities, and then here's every single column in the cities table. How would you do that? I would expect it to have more stuff. I don't know why it didn't. But anyway, and then I packaged them up as a tuple. So, any questions?
I have a question, but I looked it up on Google.
What was the answer?
I wanted to know if
the XML provider had support for XML schemas and it does.
Yeah, it is actually an Excel's SD type of understood.
I'm going to pick countries just for fun.
So in this example, country type and country mean are two different types?
Well, the countries is the table, and then it's a countries table, and then once I dot, then I will see all the columns.
By the select statement, you have C country type and C country. They look different types, right? It's not going to unify them as a string. It's going to treat them as two different types in some way.
Oh yeah, it's able to understand, like date is going to be daytime.
So if I would try to, for example, insert, right there it says insert as to left, and miss them, and switch them around, and insert country type and country name is going to type.
Yeah.
Okay, cool. Yeah, about that. Yeah. Right, cool. Nice.
Yeah, so what I was doing wrong was I was doing that in the for part instead of the select part. So here's, I could pick continent or country name or whatever I want. Oh, I already picked that. Let's say I'll pick formal name.
So I have another question.
Okay.
You didn't say C formal name. You attribute that to your program, right? Right? What will it be? Will it be just a string?
Well, it depends on what the type inference engine thought it would be by looking at the what SQL said. If SQL says it's a varchar, it's going to look like a string. If
I want to sort of create a record type, which sort of keeps them, keeps and works on them in my program. I want to retrieve stuff from the table into my record type.
Yep.
And I'm retrieving formal name and country name.
Right.
What will be the types in my record?
Whatever the type provider said they were.
Okay.
And what I would do is now that we have now that we have anonymous records, I don't need to make a type record and specify what the types are. I can just say, label and then whatever the.
Okay. So you can somehow maintain the uniqueness of the formal name and not unify them as a text or string, right?
That's correct, yes.
Okay, cool, man.
And you can do coercions or whatever before you project it. Going back to your question, always remember there's lots of different type providers, and if one doesn't provide what you want, there's probably one that does. And so you just go type provider shopping. For example, the SQL one, the one I like is kind of link-based. How many people have heard of Scott Vlashin? He's the guy that has the F# for Fun and Profit site. His favorite SQL provider is a different rival type provider. He likes to do all his SQL coding in SQL and then have the type provider that just basically provides a type-safe wrapper around stuff that came from SQL rather than doing it the link way, the link to SQL way. And you could even mix those if you want a little of this and a little of that. It's a lot of personal preference here.
Probably comes down to how complex a SQL is.
Yeah,
Yeah, like recursive CTEs, I don't think it does those.
Yeah, and that's a good point. The type providers, there are some things that are not implemented and are left incomplete. A good example of that is the database I'm using here is the World's Importers, which is Microsoft's latest and greatest sample database. It has a lot of geolocations in it. The type provider, if you try and see those, they're gone, and the reason why is it doesn't know how to handle those yet. So that's why I said there's some caveats, pick your poison. It's not entirely nirvana, but it's getting close.
It's still pretty good.
Yeah, definitely. Oh, that's it. I'm out of time. Thank you.